Hi everyone. In this video, we are going to solve a problem which is based on determinant, but there is a use of biquadratic equation or concept of theory of equation. So the question is this one: if the product of the roots of the equation a if fx equal to this determinant is p, the product of all the roots of the equation given by this determinant is p, then find the value of 2 times of p. So what we do here, first of all, we try to understand this concept. This concept we try to understand. Suppose we have a biquadratic equation, a polynomial equation whose degree is 4, and there are 4 roots, alpha, beta, gamma, delta. Then you know that sum of all the roots is equal to minus b by a, coefficient of x cube by coefficient of x power 4. Sum of the product of the roots taken 2 at a time is equal to c by a. Sum of the product of the roots taken 3 at a time is minus d by a, and product of all the roots is e by a. Sign alternately change, negative, positive, then negative, then positive. So product of all the root is e by a. E is what? E is the constant term. Now what is your a? A is the coefficient of x power 4. That means you can say that leading coefficient, coefficient of x power 4. If anyone interested to prove this result, how we get this relation between roots and coefficient, they can simply assume that suppose this biquadratic equation is equal to this one. Since they have the root x, alpha, beta, gamma, delta, so x minus alpha, x minus beta, x minus gamma, x minus delta are the factors. And we put here a to match the coefficient of x power 4 on both sides. Okay. So if we want to find out product of all the roots of this equation given by this determinant, so what we know? We are actually finding out product of all the roots. Acha, what is the degree of this polynomial equation given by this determinant? So now you can observe that one thing here in the principal diagonal, the x which are present having the maximum power. Here power is 1, here power is 1, here power is 2. So maximum power of x occurs in the principal diagonal. So when you multiply, you will get the highest power of x in this term. And that will be what? X power 2 plus 1, that means x power 4. And what is the coefficient of x power 4 here? You notice that minus 1, then plus 1, and then plus 2. That means actually it is minus 2. So here coefficient of x power 4, that is the leading term, has the leading coefficient minus 2. Now the question arises, why not other thing will be the degree? Where we consider this shortcut technique, the degree of the polynomial equation given by the product of the diagonal elements. Now consider one thing. Suppose you have this kind of determinant where off diagonal are dominant. Here 1, here x square, here x square, and here 1. So here in the principal diagonal, the x to the power 0 present and off principal diagonal are dominant. They have the maximum power. So in this case, you can't say the degree is x power 0. It is actually x to the power 4. So here our method fails. This is one example. Another example, you have to also careful about this type of determinant x, 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 and x plus 1. So now you notice that here the x power 1 term appear, and if you say that x into x square is the degree of the corresponding polynomial equation, then you are wrong. Why? Because this x square term will be cancelled out by this product. So where the highest power will be cancelling, in that case, you cannot apply this product of the diagonal elements rule. And the things where the off diagonal element has the maximum power, in that case also you cannot apply the rule. So question is, in which cases there is 100% guarantee that the product of the diagonal elements must give the degree of the polynomial. So in case of a upper triangular or lower triangular determinant, if you have the upper triangular determinant or lower triangular determinant, suppose here you have A, B, C, 0, D, E, 0, 0, and F. So in this case, it is a upper triangular determinant. So in this case, you have the guarantee this product must give the degree of the corresponding polynomial equation. If it is the lower triangular determinant also, you will get the same things. So in our cases, since x square present here, so we can say that maximum power present in the diagonal. So therefore, the degree of the polynomial equation is x power 4 and the leading coefficient is -2. So now, if you are interested that if it has a 4 roots, alpha, beta, gamma, and delta. So what is the product of these roots? What is the product of these roots? Okay. So we can say that product of the roots is alpha, beta, gamma, delta, which is equal to uh, leading coefficient, that is -2, and upper part is the constant because you are dealing with the biquadratic polynomial equation. So how do you get the constant term? Since it is a polynomial equation, if you want to find out the constant term, just put x equal to 0. So p f of 0 will give the term which is constant term. So 1, 2, 1, 1, 2, 1, 2, 1, yes. Then 1, 2, 1 also, okay. Then 1, 3, 1. Let me check it is 1 to 1 or not. 1, 2, okay. It is not actually 1, it is x in the question. So it will be 0. So we have 1, 2, 0, 1, 2, 1, 1, 3, 1. So if you want to very easily calculate this determinant, so do one thing, just 1, 0 is already present here. Okay, now. So you can do one thing, just difference, do the column 2 minus column 1. So 1, 2, 0. This, okay, you can do column 2 minus column 3. Okay, now. You will get here 0. Or if you do the subtraction from here, so this is 0, this is 0, and okay, you can do also same thing. So now 1, 2, 1, if you do the column 2, from column 2, column 1, if you minus, you will get 0 here, then 0 here, and then 1 here. And then again, if you do the column 3 minus column 1, then 0, then 1, and then again 1. So if I put, according to this, if I expand my determinant, so I'm getting what? -1. So upper part will be -1. So product of all the root is 1 by 2. And they say this product they are calling small p. So what is the value of 2p? 1. The question is very simple, but you have to understand. You don't do directly expand this determinant. It is very horrible and it is very time consuming. It is sometimes we cannot find out the things within our time. So hope you enjoy this trick, which is related to biquadratic and the relation between root and coefficients. How do you apply here in the determinant? how to calculate the constant term by putting x equal to 0, because in any polynomial, if you put x equal to 0, you will get the constant term of the polynomial. Okay, so now we will meet again in the another video. Till then, bye. Have a nice day.